Today, we're going to continue with our metric conversions, except we're going to be working with numbers that are not nice, easy whole numbers. We're going to be using what we know about multiplying and dividing by powers of 10 with decimals, mainly for today. So let's look at this first example. It says, how many meters are in 3 5/10 kilometers? So what we need to do is, in order to figure out this problem, is we need to know how many meters are, what is our conversion between meters and kilometers. I know that 1 meter is equal to 1,000 kilometers, and I can use that to help me solve this problem. Now, I could put the information in a table in order to help me understand how to solve the problem. So you'll see here, here's my kilometers and here's my meter conversion. So you'll see that I am multiplying by 1,000 to get from kilometers to meters, which means that in order to do 3 5/10 of a kilometer to meters, I'm going to be doing the exact same thing. I need to multiply by 1,000. So the thing is, we've learned at the beginning of the year some shortcuts and some tricks to help us multiply decimals by powers of 10. So we're going to be using that today. I figured it's been a while since we've talked about it. So let's start off with a little bit of a review of how we multiply and divide with powers of 10. So here's an example of a place value chart. And let's just kind of look at some number, for example, the number 3. Okay, if I want to multiply that number by 10, so this is just 3 ones. If I want to multiply this by 10, what's happening is my place value is actually shifting. My digits are shifting one place value to the left. If I want to make it 10 times greater, so this is equal to 30. If I wanted to make this 10 times greater, I have 30 times 10. I would shift my place values one place value to the left. So my number is getting greater. It's shifting one place. The numbers are shifting to the left. You'll also see that this is the same as 3 times 100. And we learned with whole numbers that when you're multiplying a whole number by a power of 10, if you look at the pattern, the number of zeros is equal to the number of zeros in your product. So 3 times 100, 100 has 2 zeros, the product has 2 zeros. 3 times 10, the product has 1 zero. So we can use that to help us. Same thing. So each time we move one place value to the left, our number is getting 10 times greater. Same thing's true. The opposite's true. So every time we shift one place value to the right, we're dividing by 10. So we're getting one place value to the right smaller. So let's go ahead and take a look at this one more time, except I want to look at this with decimals, since we're going to be looking at decimals today. You'll see here is a place value chart, and let's pretend that I'm going to start with the number, let's start with the number 42. So if I have this number 42 and I wanted to make it 10 times greater, well, all the digits would move one place value to the left. So each time I move one place value to the left, we get 10 times greater. So this 10 times greater would be 420. What happens if I would take, so this would be 42 times 10. What happens if I would take 42 and divide it by 10? Well, once again, when you divide by 10, your numbers in your place value system is shifting one place value to the right. So in other words, I'm going to put that down here. So each time you divide by 10, the numbers shift over one place value to the right. So in other words, my 4 would now be in the ones place. My 10 would be in the tens place. I need to put my decimal point here. And what you notice with the decimal point is which direction did the decimal point move? Yeah, you're right. It shifted one place value to the left. So as your numbers get big or divided by 10, you're actually shifting your place value to the right. Your decimal point is moving to the left. Anytime you multiply by 10, you'll see here the decimal point moved one place value to the right, which is why the number shifted over a place value to the left. So it's kind of complicated here, but I want to remind you that it's not the decimal point that's moving in the problem. It's the numbers that are shifting from the left to the right when you multiply by 10 or 100 or 1,000. So let's go ahead and take a look at some examples here just to review. So I'm going to have you go ahead and solve them. And once you're done solving them, I will go ahead and show you the answers. So 3 times 10, it is getting 10 times greater, which means my digits are shifting one place value to the left. So, or I'm just attaching a 0 at the end. 40 times 100, my place values are shifting 2 place values to the left. Or in this case, I can just attach 2 zeros at the end. 5 times 1,000, well, my 5 is shifting over 3 place values to the left, or I can just attach my 3 zeros at the end. Let's go ahead and look at some examples with decimals. So once again, when you're multiplying, your number is getting greater. And when you multiply by 10, you'll see that your number is getting 10 times greater. So the digits are moving to the left, which means your decimal point is going to be moving one place to the right. So we learned to just move the decimal place to the right however many times the 0 is. So in this case, I have 3 2/10. So my new number is going to be 32. So once again, my digits shifted to the left as I moved my decimal one place to the right. So if I have 4 32 hundredths times 100, my digits are shifting 2 place values to the left because they're getting 2 times greater, or 100 times greater. So I just move my decimal point 2 places to the right. And this last one here, times 1,000, well, my places are shifting 3 place values to the left, which means I need to move my decimal point 3 places to the right. Remember when we did this, we kind of drew little hops because at the end that told me how many zeros I needed to attach. So you'll see that when I get 1,000 times greater, I need to attach 2 zeros at the end here. Okay. So let's go ahead and look at some examples with division. Remember the slash sign or the fraction bar sign is also the same as division. So we have 500 divided by 10. So in other words, my number is getting 1/10 the size, or my digits are moving one place value to the right. Or in this case, I'm just getting rid of one of the zeros. In this problem here, I have 4,000 divided by 100. So my place values are shifting 2 places to the right, which is going to make this 40. Or once again, a shortcut, I am just getting rid of 2 zeros because I'm dividing by 100. 5,000 divided by 1,000, I'm shifting my place values to the right 3 times. So technically all those zeros would then just go away. Or once again, you guys may have learned the shortcut where we can just slash out the zeros. A little bit different when you get to division. With decimals, so once again, when we are shifting our place values to the right, our numbers are getting 10 times smaller each time, but our decimal point is actually going to be moving to the left one place. So in this case, if I'm dividing by 10, I'm moving my decimal point to the left one place value so that it shifts all my digits one place value to the right. So you'll see that it is 10 times smaller. 98 32 hundredths, I'm dividing by 100. So once again, I'm moving my digits to 2 place values to the right, which means that in order to do this, I need to move my decimal 2 places to the left. So then this would be 9,832 10,000ths. And then this last problem, I have 43 and 25 hundredths divided by 1,000. So I'm dividing by 1,000, which means my place values are shifting 3 place values to the right. So I'm moving my decimal 3 places to the left. And remember, if I only have 2 digits there. So in order to shift it one more time, I need to put a 0 in front of the 4. So decimal point 0.04325. So hopefully this little review is a refresher of some things we did a couple months ago. And now we're going to be going back to our metric conversions because we're going to use that multiplying and dividing by powers of 10 with moving the decimal point to help us solve these problems. So let's go back to our problem where it says how many meters are in 3 and 5/10 kilometers. So we're doing 3 and 5/10 times 1,000. So in this case, I'm going to start with 3 and 5/10. And since I'm multiplying by 1,000, my place values are shifting to the left. They're getting greater by 1,000, which means my decimal point is going to shift 3 places to the right. So I need to put 2 zeros in here. So 3 and 5/10 kilometers is equal to 3,500 meters. So this would be 3,500. Okay. Let's go down to our next problem. So we have this problem. It says 1 kilogram is equivalent to 1,000 grams. How many kilograms are equivalent to 450 grams? So once again, we're working with kilograms here. That is our base unit. So we're measuring the weight of things. So in this case, since it's already telling me that 1 kilogram is equal to 1,000 grams, I need to figure out how many kilograms is equal to 450 grams. Well, since we know 1,000 kilograms is equal to 1 gram, we need to put our 1 kilogram, we need to put our 450 grams into a group of 1,000 because that's going to then tell us how many kilograms that is. So when we do that, we're going to have to be dividing because our answer is going to be a smaller number. If you think about this, and this is kind of an important concept for us to understand, a kilometer is bigger than a gram, which means if you have a whole bunch of grams and you're trying to figure out how many kilometers that is, since you're taking that and making it into a bigger unit, your answer is going to be smaller. Let's kind of use an example that might help you make sense. If I had 2 feet and I was comparing that to how many inches that was. Well, if I converted my 2 feet into smaller units, I'm going to have more pieces. But if I had, for example, 24 inches and I was trying to figure out how many feet that would be, I'm taking my smaller units and putting them into a bigger group, which means my answer is going to be smaller. So hopefully that makes a little sense to you. So 450 divided by 1,000, well, that is actually the same as 450 thousandths, which is equal to 450 thousandths. So that's one way you could have solved this problem. The other way you could have done this, because remember, division is the same as a fraction. So I just wrote it as a fraction. This is my numerator. This was my denominator. But you can also think of this as, okay, the decimal point hangs out at the end of a whole number. If I'm dividing by 1,000, my decimal point moves 3 places to the left. So that's going to give me the 450, and I am missing my units, so that is kilometers. Okay. Let's look at the next 2 problems here. So we have, there are 1,000 millimeters in 1 meter. How many millimeters are in 118 meters? Circle the letter of the correct answer. Well, we're going to get rid of that circle the letter of the correct answer because I took the multiple choice part out. So let's look here. So it's telling us that 1,000 millimeters are in a meter. And I know I have 118 meters. And I'm trying to figure out how many millimeters that is. So we're measuring the length of something. So in this case, I need 1,000 of them to be 1 meter. So if I have 118 meters, that's 118 groups of 1,000 millimeters. So in this case, I'm going to have 118 meters times 1,000 because that's how many groups I have. So since I'm putting this into a smaller unit, my answer is going to be bigger. I'm going to have more pieces because they're split into smaller pieces. So in this case, since I'm multiplying a whole number by 1,000, I can use the shortcut of starting with my number and attaching 3 zeros at the end because of the fact that we're multiplying by 1,000. So we're just shifting the numbers 3 places to the left. So in this case, that means that I have 118,000 millimeters. And if you check your work, if you have millimeters, they're smaller. It should make more sense to have more of them compared to the larger number, which is the meters. The next question is how many grams are equivalent to 75 kilograms? So in other words, in order to figure this out, we need to know that 1 kilogram is equal to 1,000 grams. So in this case, we have 75 kilograms, trying to figure out how many grams that is. Well, we have 75 groups of 1,000 grams. So in this case, I need to multiply by 1,000 in order to do my conversion. Once again, since I'm going from a larger unit to a smaller unit, my answer is going to be getting bigger. So in this case, I do 75 times 1,000. Since it's a whole number, I can just attach 3 zeros. So 75 kilograms is equal to 75,000 grams. All right, I have a couple more questions that we're going to work on here. This is some more practice for us. I'm going to have you guys answer a lot of questions here. So this we're going to be practicing converting between meters and millimeters. So I could have written the problems out like this. So 34 millimeters is how many millimeters? We know that 1 millimeter is equal to 1,000 millimeters. So that's going to help us figure out the pattern here. So we know that each time we're converting from a meter to a millimeter, we are multiplying by 1,000. So each one of these numbers, we have to multiply by 1,000. So when we multiply by 1,000, what are we doing with the decimal? We're moving them 3 place values to the right. So in this case, multiply by 1,000, 1, 2, 3. So that would be 340 millimeters. And if you want to check your work, it kind of makes sense here. If I have 1 meter is equal to 1,000 millimeters, then your answer here, if you accidentally put another zero, it wouldn't make much sense. So it needs to be smaller. Let's look at the next one here. So 1 5/10 meters. Once again, multiply by 1,000. So we're moving the decimal point 3 places to the right. So we have 1,500 millimeters. Once again, moving the place value 3 places to the right when we're multiplying by 1,000. So these patterns start to get handy. So we have 2,090 millimeters. And here multiplying by 1,000, so moving the decimal point 3 places to the right. Once again, since there's only 2 digits there, I have to put a 0 at the end. So 3,370. If I go back and check my work, I see that the numbers are in order. They're increasing. It makes sense for them to increase since the measurement in meters is increasing as well. All right, let's look at one more example here. So this pattern in the table shows that the number of centimeters is always 100 times the number of meters. Fill in the missing numbers. So once again, we know that in order to find the number of centimeters there are in meters, we just multiply by 100. So each one of these, in order to figure it out, we need to multiply by 100. So we'll go ahead and have you fill them out. Multiply by 100, you're moving the decimal point 2 places to the right because you're making the numbers shift 2 places to the left. So that's 207. This one here, 2 places to the right. Well, that would be just attaching two zeros. We got 326 and 400. So today is really just focusing on using the patterns of multiplying and dividing by powers of 10 in order to convert. The hardest thing for us to remember is whether you need to multiply in order to convert or divide. But I just want to remind you something. If you are going from a larger, sorry, my handwriting, wow, that was really bad. A larger unit to a smaller unit. So in other words, you're going to be breaking your unit into many, many, many more smaller pieces. You're going to be using multiplication because your number's getting bigger. If you are going from the smaller unit and you are putting them into groups to figure out how many of the larger unit you have, you're going to be dividing. So that's kind of the way I remember to do things. So for example, if I'm converting from feet, or in this case, meters to kilometers, I'm going to be dividing because I'm taking my smaller unit, the meters, and putting them into equal amount of groups to figure out how many kilometers or kilometers I have. Whereas if I was going from kilometers to meters, I would multiply because I'm taking my bigger unit and breaking it into smaller pieces to find out how many smaller pieces are in that bigger unit. So hopefully that kind of helps you out and all. Also provide this for you during your practice today. So this one's a tricky one today. But hopefully you guys remember how to move the decimal place to the right and to the left based off your multiplying and dividing.